If Batman Arkham Knight came out in 2025 instead of 2015, it would need probably 16 gigabytes of RAM and an RTX GPU to run. And besides being a comment under my video, it's also pretty damn true. You've probably all noticed how system requirements for games have been skyrocketing in recent years. Of course, games are improving, acquiring a multitude of new technologies that require a lot of power. But is the way modern games look really worth the fact that they can only run on a video card that costs several $1,000s? The system requirements of modern games are growing 5 to 10 times faster than the average hardware performance. Let's take Skyrim and Starfield for example. Of course, Starfield is much more technologically advanced, but is it so much so that the difference in requirements is 20 times greater with similar gameplay density? I'm sure many of you have seen the trailer for the upcoming Deus Ex remaster, and I'm not going to talk about how shitty it looks and why anyone would even bother making it, but the craziest thing here is something else entirely. I was simply stunned when I found out the system requirements for this prehistoric piece of crap are. While the original game only needed 16 megabytes of video memory, the remaster, which isn't far off visually, needs an RTX 2080 and 16 gigabytes of RAM. Are you fucking mental? Are you fucking serious? I want to remind you that Deus Ex Mankind Divided 2016, which is an incredible game, by the way, only required an old GTX 660 with 2 gigabytes. How is it possible that this outdated remaster requires more powerful hardware than what you see on the left? It all looks really strange. It seems that the crazy system requirements for modern games exist not only because of the excessive use of various technologies, but for some other reason. But what if the problem isn't even graphics? What if your computer isn't getting weaker every 6 months, but the system requirements are simply being artificially inflated for some reason? And most importantly, when and why do they stop making games better and start just making them harder to run? When I started digging into this topic, I stumbled upon some truly shocking. Oh, people in suits are once again deciding what you can and can't watch. Screw them. That's why I use NordVPN. Not for some mysterious hacker stuff, just so no one decides what I can access on the internet. It connects in seconds, and that's it. You can stream, play, download from Berlin, Tokyo, or a small town in Denmark called Middelfart. And NordVPN also has threat protection. It automatically blocks ads, trackers, and malicious websites. So even your browser starts running faster. Plus, they've got NordPass and NordLocker, which keep all your passwords and files safely encrypted. So you can finally stop worrying about losing something important. Get a huge discount and 4 extra months for free at nordvpn.com/radicalcap, or just use code RadicalCap when you get a 2-year plan. And don't worry, if you don't like it, there's a 30-day money-back guarantee. NordVPN, the best thing that's ever happened to me in my entire life. Let's go back to 2019 when Call of Duty Modern Warfare was released, which ran smoothly on a GTX 970 and looked better than most modern shooters. Realistic lighting, complex materials, and stable 60 frames per second. Overall, the game looked great, and I would even call it one of the most beautiful games in the history of the franchise. Only the mission where we clear a house of terrorists with night vision goggles can be called the visual peak in the entire history of Call of Duty. But 6 years have passed and we see Black Ops 7, which already requires an RTX 4080, but looks significantly worse. The models are simplified, the lighting is flat, and even the animations have become less lively. Maybe they added new unnecessary technologies or just increased the number of polygons, but overall, the visual component of the new Call of Duty clearly looks more outdated than it was 6 years ago. The IW engine remains the same, but now has additional layers of post-processing, ray tracing, enclosed rooms, and dynamic effects that no one notices, but now every player pays for them. The game consumes 3 times more resources to show fewer details. The new Metal Gear Solid remaster repeats the same story. A remake of the 2004 game that requires an RTX 4080 and 16 gigabytes of RAM and still drops below 60 FPS. The reason is not even the graphics, but the architecture. The old DirectX 11 code was simply wrapped in modern RTX shaders without rewriting the geometry processing system. The result is that the GPU waits for data, the CPU waits for the GPU, and you wait for it all to stop lagging. The remake does look cleaner and more visually appealing, but does it really need such high system requirements? I would also like to mention Doom: The Dark Ages. ID Software, once synonymous with optimization, now recommends 32 gigabytes of RAM. The reason is technically logical. The ID Tech 9 engine stores multiple layers of textures and shadows in memory at the same time to avoid pop-in, which is when objects or textures suddenly appear in front of the player's eyes because the game didn't have time to load them in advance. But this means that the computer processes scenes that you don't even see. In other words, what used to be solved by precise code and memory limits is now simply solved by, why should we bother with our code when we can just specify inflated system requirements to ensure that players don't see any artifacts? And finally, Sid Meier's Civilization 7 released this year. A typical turn-based strategy game, which visually has hardly changed from previous installments, now somehow requires a much more powerful computer. The game now renders everything in full 3D with dynamic lighting and volumetric effects, even when you look at the resource table. As a result, you need an RTX 2060 to play a game that should run on an office laptop. Let's be honest here. Today, most games are not becoming more complex. They have simply ceased to be economical. Data is duplicated, caches are not cleared, and engines keep scenes in memory that you will never see. We clearly see a loss of control over how many resources are being burned, and perhaps that is why we see such crazy system requirements for new games. But then here a logical question arises. Do developers have a real opportunity to reduce these requirements? High system requirements are not the result of technological progress. They are the result of a strategy in which no one is interested in making games efficient. When hardware becomes more powerful, the industry simply stops counting every megabyte, because now there is no need to. Video card manufacturers have to sell a new generation every single year, and every time a game comes out that doesn't run on the old card, it's the best advertisement for new GPUs. Game engines also work not for efficiency, but for versatility. That's why we see Unreal Engine 5 becoming so popular, and it doesn't matter that it's too heavy for the hardware. Developers need to support everything, any formats, any effects, any scales. That's why there are always dozens of subsystems working inside a modern game that no one even sees. Memory is not spent on the player, but on the variability to support everything at once. This is beneficial for developers. They no longer have to deal with low-level optimization. The engine does everything for them, and the studio just ticks boxes in the menu. This saves months of work, but it kills control over how much the game actually consumes. Every year, this looks like progress, but technically, it's a breakdown of technical discipline. And then comes marketing. At the presentation, everything has to look cinematic, even if the player doesn't notice it. That's why the final version leaves in the blur, shaders, and tons of post-processing, everything that looked good in the demo. And even when the developers see that the game is barely breathing, no one risks fixing anything or even optimizing it. This is how next generation games appear, which look like the previous generation but consumes like the next 3. And when the developers say that the game is not designed for future hardware in mind, it just means that it has not been optimized for the present. This has consequences. Today's games are not scaled to the player. The player has to scale to them. And the average PC, which a few years ago was considered a gaming PC, now simply cannot even run modern games. This is convenient for the industry. For the players, it's expensive. And for the game itself, it's devastating. Because the fewer restrictions there are, the fewer ideas there are. Optimization has always been about more than just speed. It's about design. It's about understanding what to show the player and what not to show them. But the most interesting thing here is that it's not just gamers who suffer from this. An entire layer of developers is disappearing because of it. Previously, there was a huge space between indie and AAA, the so-called AA segment. Teams that could make a game for $10 million and still look no worse than a blockbuster. Now, this segment is simply being washed out because the price of entry into the industry is determined not by talent, but by whether you can afford Unreal Engine 5, motion capture, and a fleet of RTX test cards. Technologies that were supposed to simplify development have actually made it a privilege of large studios. As a result, the industry is becoming monotonous. It's no coincidence that gamers experience deja vu. Every game now goes through the same algorithms. So when you launch a new shooter and it seems like you've seen it before, you really have seen it before, just under a different logo. We are so used to upgrading our hardware for the sake of new worlds, but it seems that we are now upgrading only to keep those same worlds from freezing. And when a game requires more resources than it gives emotions, it is no longer a game, it is a benchmark.